So think of when an AI agent doing a long task, is it just thinking continuously? No. Like if you give it a problem and it's just sitting there remembering everything step by step until it finishes. So that's not actually what's happening at all. What really happening is a bit more engineered. Behind the scene, every single step is breaking, rebuilding, and continuing again and again. So the model itself does not remember everything. So if you pause the system at any moment and remove the surrounding setup around it, and so the model would have no idea what it was doing 1 second ago. So the real question becomes, how do the system still manage to do long tasks? How does it read files, fix bugs, run the tests, and continue like it has a memory? So the real question is not inside the model, but the system around it. So what we are going to do is break down that exactly system and see how different things work, like how the context is stored, how it is rebuilt, and how the compression works when it grows too big, and how different pieces of memory files and skill fit into this whole flow. So by end of this, instead of thinking the AI remembers, you will clearly see that it's actually a loop of storing, selecting, compressing, and replaying context every single time. So once we understood that the model itself is stateless, that it has no memory between API call, it is not aware of the earlier API calls and their responses, then comes the important part, that is storage. So if nothing is stored, there is nothing to reconstruct the context from. So as the system runs, every action is written somewhere. You can imagine this as a file that keeps growing in real time, something like a log.json file. So now what goes inside that file is that every user message get appended here and the response also get appended. So if the system reads a file, that action and its output will get appended to that log.json file. So if it runs a command, same thing will happen. Any command that will be run, its output and that command it ran, it will be stored in the log.json file. So instead of each API call will get disappear, we now have a full execution history building up here. And this becomes our base layer. And the important part here is this log is not what we call directly sent to the model, because if we do that, it will very quickly become too large. And so storing is just the step one here. The real work will start when we decide how to use this stored data. So instead of treating this entirely as one block, the system starts separating things based on how they are used, because not everything needs to go into the model every time. So alongside this full log file, we introduce another layer, the working context, like context.json file. So this file is like the active session. So while the log file is like complete diary, this context is more like the current workspace. So here only the relevant steps live here. So instead of carrying everything forward, the system keeps just enough information here to continue the tasks smoothly. And there is also something that doesn't depend on the conversation at all, which is memory. So this is usually stored in something like memory.md file, and this is where stable information lives. So stable information, I mean, instead of repeating some information again and again in the conversation, we store them once here, like the project rule, constraint, and preferences. We can think of like example, don't change the particular API, auth logic is in that particular file. So we store these kind of things in memory file. So on top of all this, we also have skills. So as we already know, these are the predefined ways of doing things. So instead of the model figuring out from scratch how to debug or test, we give it a structured guidance. So when a new step is about to happen, the system doesn't just pick previous messages. It builds context by pulling all these layers together and builds a final context to send to the model. So it picks some recent steps from the session. some stable knowledge from memory, and some structured behaviors from a skill. So what the model sees is not the raw storage. So it assembles all of this and sends to the model that it actually needs. If we zoom into this working context, the way it's stored is also important because it's not just a simple list of messages. Each step is stored as a structured entry, and these entries are connected to each other. So every entry know what came before it. You can think of it like a chain where each step is linked to the previous one. And when a user message leads to an assistant step, that leads to a tool call, and then leads to a tool result, and then that can lead to the next step, and so on. So over time, this is basically forming a continuous execution path. So now when the system need to prepare the next API call, it doesn't just randomly pick data. It just start from the latest step and follows this chain backward, and it goes back. It keep picking the relevant steps. So in a way, what it's doing is it's replaying what just happened instead of trying to read everything from the beginning, and that reconstructed path becomes the context here. So now, even though internally this is stored as a connected structure, what we send to the model is still a clean ordered sequence. So for the model, it just look like a normal conversation, but behind the scene, there is still this structured session keeping everything consistent. So as more steps keep happening, this chain keeps growing, and more file reads, more outputs, more logs getting added. And this is where we run into a real problem here, because no matter how we store things, the model has a context window. It can only take a limited number of token. So if we keep adding more and more history, at some point it wouldn't fit. So now, instead of cutting things randomly, the system introduces compaction. So this is where things get interesting, because we are not just trimming, we are compressing the data here. So earlier steps, like reading multiple files, identifying a bug, making initial changes, these don't need to stay in raw form forever. So the system summarizes them. Now, instead of sending all detailed data again and again, we send a compact version of what happened. Something like investigated auth flow, found missing token handling, and applied the fix. So a large chunk of context becomes a small meaningful summary here, and this compaction triggers based on the token limit. Like as the system prepares the context, it estimate how big it will be. So if it's getting close to the limit, compaction kicks in automatically here, and older entries get summarized. So the recent entry will stay detailed. So because the latest steps are what the model needs to act on next, so the context now becomes a mix of compressed past, a detailed present, and that keeps everything within limit without losing the continuity. So when you see this running end to end, everything starts connecting together. For example, if we give it a same login bug example, but we will walk it through slowly, seeing each step. So the user sends a request like fix the login bug. That message that message doesn't just go to the model. It first get written to the log file, and so now it's part of the system memory now. Then before the model is even called, the system prepares the context now, what to send the model. So it takes that request, then it looks at the current session, whatever recent step exists. Then it adds the memory, like rules such as don't change public API, and the hard memory we have rules. And there is a relevant skill also, like debugging or testing, that's included as well. So by the time the model is called, it's just not seeing one line, it's seeing a complete setup of what needs to be done and how to approach it. So from there, the model decides the next step. Let's say it starts by reading the login file. That file content comes back through a tool, and that result gets stored. Now the system has more information here, that it might read another file, maybe auth logic again, and that result again will be stored. So step by step, it is building understanding, and every step is being recorded. At some point, it will have enough information and it identifies the issues. Now it decides to make a change and it edits the code, and that change is stored as another step, and then it run all the test. The test output comes back, and maybe there is a failure that will also get stored. And now when the system moves to the next step, it doesn't just send everything that ever happened. It builds the context again, but this time it selects what matters only. It includes the original goal, the recent action like the file edits, the latest output, and the test failure, and again memory and skill if needed. So the model continues from here, not from the scratch, but also not overloaded with everything that has ever happened. Now is this Now as this process keeps going, more steps get added, more reads, more edits, more output, so the session keeps growing. At some point it becomes too large that when compaction happens. So the older step, like the earlier file reads and initial investigation, gets summarized. Recent step like the latest test output or the last edit stay detailed. So now instead of carrying everything, the model gets a compressed version of the past and a detailed view of the present, which is exactly what it needs to continue. So even after compression, it still knows what the goal is, what has already been done, what is currently failing, and from there it continues again. And this loop just keep repeating. That first store the step, rebuild the context, add memory and skills, compress if needed, and call the model, and then store the result, and again the whole cycle gets repeat again and again. So even though the model itself is completely stateless, the system around it keeps rebuilding the state every single time. And that's what creates this feeling that agent is continuously thinking and remembering. All right, that's it for today. And turns out the intelligence system is just really good at keeping the notes.